All right. Yesterday we looked at this picture right here. And if okay, here is my F graph right here. Now let's go through these 7 scenarios right here. Okay? Right now, since this graph is decreasing, we would expect F prime, the slopes, to be what? Negative. If F is decreasing, then we'd expect F prime to be negative. Okay? And then through here, it switches to positive slopes, and then it's 0, and then it goes to negative slopes, and then it's 0, and then back to positive slopes, right? Okay? Now let's go ahead and actually look at a plotting of this. Okay? Let's look at what the F prime graph would actually be. So let's take number 1 there. If F prime is positive, when's F prime positive? Right here. That green dot is above the x-axis, and this is when the blue graph is doing what? What's the blue graph doing right now? Increasing. Increasing, still increasing, still increasing, still increasing until there. Now that entire time the green dot was above the x-axis. So when F prime is positive, this graph is increasing. And back to right here, the green dot is positive, so the F graph is increasing. Okay? All right. Then we talked about switching from positive to negative. There they go. All right. See that? They're the ones that really need it. We got the smart half still here. All right. Well, we'll go through it anyway. All right. All right. Oh, is it bad? Am I backward? Okay. So let's look at number 3. If F prime switches from positive to negative, okay. Well, where does the green? Whoops, that was no good. Okay, the green graph or the green point switches from positive to negative when? Right here, right? Right through here is when the green value switches from being positive to being negative. Now, what is that point on the blue graph? Local max. F prime switched from positive to negative right there at the local max. And that's what we said in number 3. When F prime switched from positive to negative. Okay, the slopes. How about when it switched from negative to positive? That happened right here. F prime is negative because the blue graph's going down. And right here it switches from negative up to positive. And that's at a local minimum. And also right over here. The green dot is negative and switches to positive. We have a local minimum. Okay, let's go to number 5 over here. If F prime is increasing, when is the green one increasing? Well, right now it is. Right now the green dot is increasing. Increasing, 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 still increasing, all the way to there. All the way to there. Now, what point is P at right now? It's at the inflection point. The entire time that green dot was increasing, this graph was concave up. When F prime is increasing, F is concave up. Now, the green dot is going to start decreasing. The slopes are decreasing now. They are decreasing all the way till about there. What do we got? Concave down, and there we are at another inflection point. So the peaks on the green graph, this peak here and this peak down here, the max and the mins, those are the inflection points. When the green graph switched from increasing to decreasing, we had an inflection point. Then it switched from decreasing to increasing, we're at another inflection point. Okay, the rest of the time, the green graph will be increasing, and that's when the blue graph is concave up, and that's that one right there. So you can see those interactions, and now we'll look at the F prime graph right here, okay, and there's the actual graph of it. Now, for those of you that were able to spend some time under the homework, which one was the hardest one for you on 21 through 36? 33? Absolutely. I think 33, I would have expected 33 to have been the hardest one. And what did you have to do on 33? Sketch the F graph from the F, or they use G, but same idea, right? We had to sketch the G graph, and all we had was the G prime graph, right? All we had was the G prime graph. Now,
you need money today?
You got something for me, Nate, or you don't got anything for me? Okay. So this is like yesterday when I said pretend you can't see the blue graph, right? Pretend we can't see the blue graph. That's what 33 is like. 33 is they give you the green graph, and they want you to draw the blue graph. Okay? So, again, I would be thinking about these things over here. I'd be saying, okay, what's the green graph doing right here? Well, it's doing two things. One thing is it's negative, right? The green graph's below the x-axis. What's the other thing the green graph's doing? It's what? It's going up, right? So right here, the green graph is negative, but it's increasing. So if I look at the F prime over here, when it's negative, I've got a graph going down for F. And when it's increasing, I got a graph that's concave up. So I know the blue graph right through here has got to be going down and has got to be concave up. Right? And that's what's happening. Until right there. And then what I would say is, now I see F prime changing from negative to positive. That's number 4. When F prime changes from negative to positive, I know I got a local min. So I know my blue graph will have a local min. Now I see the green graph being positive and increasing. Right? That means my graph's got to be going up, and it's got to be concave up. Okay? Now up here, I see my graph still being positive, right? But switching to what? What's F prime switching to here? Well, yeah, it is that's a great point. F prime is concave down. I said switching to it because it's concave down here and it's concave down here, right? But F prime is concave down. But then I look at my list, and do I have anything in here about F prime being concave down? F prime being concave down. And I don't, right? So that's a true statement, but it really doesn't tell me anything, right? So what else is F prime doing right through here? It's decreasing, right? So right in here, the green graph, F prime, is positive because it's above the x-axis, but it's decreasing. So since it's positive, my graph is still going up, but since F prime is decreasing, F is concave down. So what happened is I switched from concave up, and I switched to concave down. Now that keeps going on until right there. So what's happening here, what I hope you're getting from this a little bit, is that as I look at the green graph, I was kind of looking at it here until right there. That was something important happening. And then I was looking at it until about right here, and then something else important happened. Now on the first one, it was my local min. On the second one, it was my inflection point.
Is Derek Schreiner here?
No.
He's not. All right, nice.
Nope.
All right.
Brittany here today? She went to get a picture taken, so she'd be down the South Gym. Okay, thanks. Okay? Busy place. All right. Then I was interested until about right there. Right? And now, okay, right here, this is switching from positive to negative. So when F prime switches from positive to negative, I've got a local max. Okay, sure enough, there's my local max. Now it's negative, so this starts going down, and it's decreasing, so it's concave down, until about right there. Now this is still negative, but now it's increasing. So if F prime is increasing, I've now switched to concave up. Sure enough, concave up. And that happens until right there. Right there, F prime is switching from negative to positive. Switching from negative to positive means you got a local minimum. Sure enough, right there. And then the rest of the time, F prime's positive, so F is increasing the rest of the way. And so that's how I could have drawn that blue graph looking at the information in the F prime graph. And that's what we have to do on 33. And we'll do that together, but I might wait until the other people get back as we look at it. So we have some other ones we got to look at anyway. Yes?
The problem that I have is determining which version of concavity it has. Like, I can tell that it'll be concave up, but I can't tell if it's going concave up getting bigger or being negative.
You mean like that?
Less negative.
Or like that?
Yeah.
If it's one of those two.
Yeah.
Okay.
I have a hard time telling between the two.
The key is these two working together. Okay? Right here, in this section, okay, because the green, let me erase this. You know something I just realized? As I'm recording this, the person is not seeing all this stuff I'm writing on here. It's not on the computer. So let me answer your question by doing it on here. So, because there's two things, and the secret to that, Wyatt, is right here. Let's put this in red. Right here, okay, the F prime graph is negative, right? And then here the F prime graph is positive. So we have a switch from 1 to 2 there, right? But this whole time F prime is increasing, correct? Now F prime increasing means it's concave up, right? So on this one, what you have is negative and increasing on F prime. That means, let me write that down, that's F prime. So that means F is increasing, that's number 2 up there, right? And if F prime is increasing, that means F is concave up. So that tells me this graph, oh whoops, you guys need to speak up. What did I just screw up there? What did I just screw up there in the red?
F prime is negative, it's going up.
What should that be? That's going down. If F prime's negative, it should be going down. Okay, so right through here, my F prime graph is negative and increasing, so my F graph is increasing and concave up. So, or decreasing and concave up. Okay, so this graph is decreasing and concave up. So that's the version of concavity you have. But then here it switches to F prime being positive and increasing. So therefore F is now increasing and concave up. So that's the other version of concavity, if you will. Does that make sense? So yeah, just the fact that this is increasing means it's concave up, but you don't know if it's doing this or this. That's based on whether it's below or above the x-axis. Okay? That's the thing. Now, again, like I said yesterday, this is a lot of stuff that we've written on the board here, all those connections that we have. What I want to do, with that next is I want to make that a little better organized. Okay, so let's go ahead and let's just do that now. And this is something that the rest of them can catch on to when we get here. So I'm going to do a little work with this. Okay, and let's see how this works. What am I looking for here? Okay, seems to be working. All right, and how far over here can I write? Is that showing up?
Yep.
Okay, that's kind of my limit. All right, so let's go ahead and put this in. You're going to want to put this in your notes.
Oh,
I went a little crazy.
Okay. Thank you.
There, you got some.
There you go.
Way too far left.
Too far? Am I too high?
No.
No,
How high is
right
that?
Put a
there,
mark
keep
down and
going.
find out where it is.
Keep going like that.
There you
Yeah.
go.
What about that? It don't have.
That's like on the board.
That's the one I kept looking at. Did you see that? Come on. Okay.
Yeah, pretty much.
All right. So, in our notes, you guys are just in time for the world famous chart. The chart. Ask anybody who was in calculus last year about the chart. And they now that why is that?
Why is that there then?
That's way up high, and that okay. I got that too high in the board though. All right. Well, that we just have to do. All right. What we are going to do is take all of these connections that we have listed here and that we just referenced as we were looking at that FF prime connection, and we're going to organize it in a much nicer way. All right, if you ask anybody from calculus last year about the chart, they could probably draw it out for you. They won't remember anything else from last year, but they might remember the chart. Okay? On our next quiz, my guess is when I pass out the quiz, before you ever put your name on the paper, you will write out the chart. So we're just going to take those things and try to put them in here somewhat organized. So the first thing, and we'll start with the F prime row, and we're going to call that, we're going to say the first thing that F prime could be is 0. Okay? If F prime is 0, then F has a stationary point. Okay? By definition, that's a stationary point with a derivative of 0. Now, we won't get into critical points that much yet. We know critical points are where the derivative is undefined or 0. Okay? Stationary points are just where the derivative is 0. Now, one of three things can happen at a stationary point. What are those? How's that coming over there? Not bad. Local min, local max, flat spot. Okay? Local min, local max, and flat spot. All right? F prime in the next column over, F prime could be positive. If F prime's positive, what's F? Increasing. If F prime is negative, F is decreasing. There's 1 and 2 over there. What about 3 and 4? If F prime switches from positive to negative, that then would just be switching these two columns. So the first derivative test, 3 and 4 over there in our notes, that's just these two columns switching places. Okay? If F prime switches from positive to negative, then F would have to switch from increasing to decreasing. And if F switches from increasing to decreasing, you've got a local max. So if I switch columns here, that tells me what I need to know about number 3 and 4 over there, about local max, local min. Okay? All right, number 5. If F prime is increasing, F is concave up. And if F prime is decreasing, then F is concave down. And what happens, number 7, if I switch those columns? Not switch the columns, but if I go from one column to the other, what do I got? Inflection point. Because if F prime switches from increasing to decreasing or from decreasing to increasing, then my F columns have changed, and I've changed F has changed from concave up to concave down. Therefore, I've got an inflection point. Okay? So there's all those things that we listed over there, summarized there. If you just think about the F prime row, you can usually get the F row from that, just 0, positive, negative, increase, decrease. We're going to add to that tomorrow when we bring in F double prime. Okay? and bring in the second derivative and those connections. So we'll add to this. But for now, okay, we've got that information. So that can be helpful to us. Ooh. Okay? I don't know why it doesn't.
Did you,
Okay?
well, like, I was thinking if maybe, like, you used it to point, and
Hey,
it's like some
Here's what happened. Here's what I think happened. When you press on this, I don't know if you can hear it. There's a little buzzing. There's a little buzzing, and that activates this thing, and then the sensor picks up the movement of the pin, and that's how it writes those things. When I put the cap on, if I'm close to the board, when I put the cap on, that pushes it in and it buzzes. And so if I put the cap on, and I can push it on it, and then
Whoa.
see. So I wasn't even right, but I was pushing the cap and I was moving it around near there, and the sensor was picking it up. So a lot of times that's what's happening. All right. So there is a nice summary of those things. So now let's go to the homework. Now this, I think for many of you, is going to make the homework seem easier, hopefully, as we look at it. The homework, 21 through 36, is a lot of what your next quiz will be about. Okay? So if we could look at these problems here, starting with, well, I tell you what, let's look at 25. Let's focus on 25 through 36. Because 25 through 36 refer to this picture here. Okay, 25 through 36 refer to this picture. Now, all right. Now, one thing to keep in mind, and I mean this as a positive, but the next quiz, if you look at 25 through 36, it's like 12 questions, all referring to this graph. Now, our old book, this was one problem on the homework, and it had 12 parts. Okay? Like on today's homework, we have several problems that have multiple parts to it. So it doesn't seem real long, but it does have some stuff. So I'm going to give you quite a bit of work time today on the homework as we put this stuff together. But that's kind of what the quiz will be about. You know, where is this increasing? Where's the local max? Where's the local min? So I really want to talk a lot today about how to write these answers. What are we looking for? It has the potential to be a easy quiz. I mean, it has a potential for you to do well. The danger is, if you haven't really kept up with things and practiced on the homework and really kept these things organized, then, as you'll see, as you go through 25 through 36, if you get one wrong, you tend to get a whole bunch wrong. And that's the danger. So really work hard at getting the connections here. And as you went through these, if they felt fairly easy, that's a good sign that you're getting these connections already. If you're not getting the connections, they usually will come. Okay? It just takes, it's understandable. That's why we're on our third day of this. The blue graph is the G prime graph. In the red, we're going to do the G graph. That's number 33. Okay? But let's build up to it. So 25 says, where is G increasing? Well, look at the chart. G is increasing when G prime is positive. Sort of. So what'd you put for an answer?
0 to 1, not including 1.
That's the key. Do we include 1? Is it acceptable to say 0 to 5.5 for the answer to number 25? Anybody look in the back?
I think that's what it says there.
I think that's what the back had, and that's right. And then don't forget 9 to 10. Now let's talk about that. It's a little bit of a technicality. The chart does a nice job of summarizing things, but it doesn't really get all the technicalities in there. So let's talk about it. The graphs, the question was, where is G increasing? Okay? Well, G is increasing when G prime is positive. Think of the x cubed. It's always increasing, even though it flattens out, right? So there is one time where the slope is 0, not positive. But the graph is still always increasing. So to answer the question, where is G increasing? It's wherever G prime is above the x-axis. That can include where it hits the x-axis. But now what if that question was, where is G prime positive? And you think that's the same question. Where is G increasing? You think it'd be the same question as where's G prime positive? But it's not the same question, right? Where is G prime positive? Could you include 1? G prime is not positive at 1. It's 0. And 0 is not positive. So in that question, you'd have to say 0 to 1, 1 to 5.5, and 9 to 10. Okay, so understand, just a very subtle difference there. But understand it. Okay, 26. Where is G decreasing? Well, that'd be when it's negative, and that'd be from 5.5 to 9. Now on the homework and on the quiz, I sometimes give you a graph like this. You're just estimating. We don't know that that's 5.5, I don't think. Do we? Did they tell us that? They didn't. Sometimes in the directions, though, they'll say, well, G prime has roots at 1, at 5.5, and at 9. So they're telling you where G prime crosses the x-axis. So those are the numbers you should use. Okay? Let's go on to 27. Where does G have stationary points? What do you say?
5, 1, 5.
Stationary points are when the derivative is 0. This is the derivative, so where it's 0 is where it crosses the x-axis. 1, 5.5, and 9. Okay? Now, that's how I want you to write the answer. Here's something I often see people write. They'll say, the question says, where are there stationary points of G? Well, that's where G prime is 0. And I'll see people look at this point right here and want to write 1, 0. Don't do that. Don't write it as a point. They want to know where. They want to know the x value. And that's wrong anyway. The question said, where does G have stationary points? Why would that be wrong to say that?
Because on the graph, it's not necessarily on the x-axis.
Yeah, where's this point right here? That's on the G prime graph. The point 1, 0 is on the G prime graph. We don't know where the y value on G is when x is 1, right? So it would be wrong to say this anyway. So just say when x equals 1, 5.5, and 9, those are the stationary points of G. Those are the places where G prime equals 0. Means where it crosses the x-axis. Okay, where does G, and that's why I'm making a really big deal about this because, well, a lot of it's because it's on the next quiz, and these are the kind of questions you're going to see a lot of, okay? Where does G have local max points? Okay? We're looking for this right here. We're looking where G prime goes from positive to negative. Look at the chart. Where G prime goes from positive to negative. Okay? Where does that happen? Right there. 5.5. Local min, right there, at x equals 9. And that's all you say, x equals 9. Does it say justify? It didn't say justify in those cases. Next one, is G concave up at 3? Yes or no? Yes. Why? It says justify. Why is it concave up? Because G prime is increasing. This graph right here, the G prime graph is increasing. G has to be concave up. How about at 6? No, it's concave down because G, see I did it, I said it. G is concave down because G prime is decreasing at 6. So it's not concave up. 32, G prime has a local max point at 3.8, right there. Has a local min at 7.4. What does this say about G? Those are inflection points, and that's over here. If G prime switches from increasing to decreasing, which is what happens, G prime here is increasing then decreasing, decreasing then increasing, that's when we switch on G from concave up to concave down, vice versa. So we have inflection points. Now, it's misleading. These aren't inflection points on this graph, but on the G graph, they would be inflection points. Okay? 33, we're going to come back to. 34. Let's clear this off. 34 asks for the equation of the tangent line. We know whenever we have to write the equation of the tangent line, we write down, we need a point and a slope. So they tell us g of 3 is 4. So we need the slope. We need g prime of 3. What's g prime of 3? Right there, it is 2. So g prime of 3 is 2. That's the output there. So that's our slope. So what's our equation? It's y equals our slope, x minus 3 plus 4. That's all you do. And then 36 is the same. 35 is the same kind of thing. Right? We need a point. They gave us that. We need the slope. We get that off the g prime graph. We write the equation of our tangent line. All right. Now let's do 33, and then we can come back to 36. 33 said they wanted us to draw the g. They want us to draw the g graph. Okay, so here is the g prime graph. So in red, let's draw the g graph. Now, this is taxing. All right. So the g graph's going to be in red. Now, they told us that g of 0 equaled 0. What does that do for us? So it gives us a place to start, right? Okay, so it gives us a place to start. Now, I was just showing this, for those of you that weren't in here, I was just showing this on the other computer software thing. What is this graph, g prime, doing until here? It's, no. Now, let's careful what I said, and maybe I did say g. I meant to say g prime. What's the g prime graph right through here? It's two things. It's positive and it's decreasing, right? Now, according to the chart, when g prime is positive, what's g got to be doing? Going up. So my graph's got to be going up. Since this g prime is decreasing, what's g? Concave down. That's number 6, right? Or it's in the chart over there. So my graph needs to be going up, but be concave up. Now the question is, how steeply is it going up? Well, I'm not going to worry about that too much right now, but we do have enough information to know. I mean, look at this. These blue y values are the slopes of the graph I'm drawing, right? So this says my slope should be 1 to start, and it should be getting less than 1. So that would tell me as it goes up, I should probably not go up past 1, should I? Right? Because I shouldn't go over 1 and up 1 if my slope starts out 1 but then gets less. See that? All that stuff's in there. Okay, now we're going to look at the graph from here to here. What's the graph right through here? Increasing and positive. That means my graph's got to go up and be... So what kind of spot do I have here? Flat spot. Sure, this was positive and stayed positive. So this graph is still going up. So this graph's going up and it's concave up, and who knows how steeply, and that happens till there. Okay, now what happens right through here until here? It's positive, so my graph's still going up, but it's decreasing, so my graph is going concave down. Oh, that's bad. So my graph is increasing and concave down until about there. Right? Now, what do I got? Negative, which means my graph's going down. See, I went from positive to negative here, so I should have a... No. If f prime goes from positive to negative, I should have a number 3 over there. If f prime goes from positive to negative, I should have a local max, shouldn't I? Okay? Now this graph is, this is negative, so this should be decreasing. Sure enough, there's my local max, and it should be concave down. Right? Until about there somewhere. So since this is decreasing, this one's going to be concave down. Since this is negative, this one's decreasing. All right, now what happens right through here? negative, but it's increasing. So that means this graph is going down, but it's concave up until there. Now this blue graph, the G prime graph, is going from negative to positive. What's that give me? Number 4 right here, going from negative to positive, should be a local min. Sure enough, looks like it's going to be, because right here I've got positive and increasing, so my graph's going up and will be concave up and something like that. So there is my G graph. Good. Now, here's my next question for you. What if they would not have told me G of 0 equals 0? What if they would have not have given me a place to start? Could have started anywhere. Think about it now. What if I'd have started here? And I'd have asked myself all those same questions. I'd have said, okay, my slope is positive but getting less positive, so that's doing this until here. Now my slopes are positive and getting more positive, so that goes like this until here. And then my slopes are positive but getting less positive, so that goes like this to here. Now they're negative and getting more negative, so that goes like this to there. And now they're negative but getting less negative, so that does this. And then it goes like this. What I got? That's not bad. Same graph with what? Vertical shift. It's the same exact graph for vertical shift. How many of those could I draw? A lot, yeah. Or to use a less technical term, infinite. Right? Yeah. So what's that tell us? One F prime graph would have an infinite number of F graphs that would go with it. Now, if you think about it a minute, that makes sense. Because an F prime graph is just a plotting of the slopes of the F graph. Well, if I don't think parallel is the right term, but you know what I mean, right? If these graphs that are all vertical shifts of one another be kind of like parallel to each other, right? Doesn't the green graph here have all the same slopes as this graph? So if I plot the slopes of the green graph and then plot the slopes of the red graph, it should be the same graph, right? So if you take graphs that are just the same graph except vertical shifts of one another, they should have the same F prime graph, the same slopes. Okay, so that's an issue then if you get a problem like 33. If a problem like 33, if they give you an F prime graph and ask you to draw the F graph, your first question would be, where should I start? And if they don't tell you a place to start, then you just start anywhere. Just start anywhere. Okay? All right, so there's 33, which is a tricky one. Now in 30s, that makes 36 much easier because now they ask you, could x times sine x be the F graph or the G graph? Well, just get on your calculator and graph it, see if it looks like this. If it looks like this, then yeah, it could be. If it doesn't look like that, then no, it couldn't be. Okay? All right. So, the rest of the period is going to be yours to work on the homework. Okay? Now, on your sheet where it says 1.6 day 2, okay, I want you to do all of those, except I want you to add 54 to the end. 54 is a little bit more of the matching the graphs like what we did yesterday. So 1.6 day 2, all of those plus tack on number 54. Now it's more of this, it's all what I call chart stuff. The questions are, where's it increasing? Where's it decreasing? Where's the max? Where's the min? Where's it concave up? Where's it concave down? That kind of stuff. Really work on trying to get this chart thing organized in your mind, be able to answer the questions, give the intervals. Some of those questions are somewhat long. Some of those questions have 5, 6, 7 parts to them, you know. And some of the ones at the end you graph on your calculator. So instead of me giving you a graph of G prime like this, I give you an equation and you graph it on your calculator. So get yourself a nice viewing window where you can see it and then answer the same questions that, just like we did here. All right. If you were gone last time and want to do the matching activity, that's great. You can do that now, or if you want to do it another time, or if you don't want to do it at all. It's not a graded thing, but if it may be helpful if you want to do it. Okay, totally up to you.
No.
That's good.
I could grab that.